Research methods for honors psychology. Today we're going to focus on how psychologists ask and answer questions. First thing we'll talk about is critical thinking. Critical thinking is something you should have heard throughout your education. Right? Teachers say this all the time, right? We want you to think critically. So what is critical thinking? Critical thinking is thinking that does not blindly accept arguments and conclusions. It examines assumptions, discerns hidden values, evaluates evidence, and assesses conclusions. Right? So when you're told something, you don't just believe whatever you're told. Especially nowadays with the internet and social media, there's so much stuff on the internet, and sadly, most of it is not true. So when you see something online on social media, you have to look at it and you have to critically think, right? Is this true? Is it biased? Where's the source of this information? Could it be a lie? Right? So you have to critically think all the time, especially nowadays with the internet and social media. False consensus effect. False consensus effect is when people assume that their own opinions, beliefs, preferences, values, and habits are normal and that others also think the same way that they do. An example of this could be, oh, America is the best country to live in throughout the entire world. Everyone wants to live in America. Now, some people believe that, but definitely not everyone believes that. And if you watch the news, there's a lot of people that don't believe that. But if you are one of those people, right, you're going to think everyone else thinks the same way you do. Now, if you think for a second, do you know anyone like this who says stuff like this all the time? With different examples, but they think everyone else thinks the same way they do. I definitely know people like that, right? They always say, oh, everyone thinks this way. No, but everyone doesn't think that way, right? It's that false consensus effect. I know some women, they think because they think that all other women think the same way they do. But of course, we know that's not true. Same thing with males, right? They think because they think this way that all males think this way. Of course, that's not true. Hindsight bias. Hindsight bias is something you'll see all the time now. And that's something with psychology. And a great thing about psychology that students love is a lot of the terms we talk about, a lot of the ideas we talk about in here, you're going to see in your everyday life. Hindsight bias is one that you might already know, but you'll definitely be seeing this throughout the year. And students love to be like, oh, that was hindsight bias. All right, so be on the lookout for it because you'll definitely see it. Or as we talk about it, you'll think about times in your life when you've had hindsight bias or seen other people with hindsight bias. So what is hindsight bias? It is the tendency to believe after learning an outcome that one would have foreseen it. Right? It's also known as the I knew it all along. So when I always think about sports, like football season. So on Mondays, a lot of times I'll come in like, oh, I knew this team was going to win. Well, if I knew that team was going to win, why didn't I pick them to win? But I picked the other team. All right, so if I knew they were going to win, I should have picked them, but I didn't. All right, so when I come in and I say that, I'm showing hindsight bias. Right, and I see this all the time on tests. If we'll be going over a test, assume like, oh, I knew that was the answer. Well, if you knew that was the answer, why didn't you put it? All right, that's hindsight bias. So what I want you to do right now in your notes, just write 1 through 6. You don't need to write the statements down. You just need to write 1 through 6, read each statement, and then for each of the numbers, either write, is this statement true or is it false? So you could just put T or F in your notes. All right, so read each one, put true or false, T or F. So right now, pause the video as you read each statement. Right, and then when you're done answering each statement, then you play the video again. Now here are the answers to those statements. Now read through and see which ones you got right, which ones you got wrong. and then you go back in the video and look at the statements. Now, as you're looking at your own answers and the statements, did you notice you saying, oh, I knew it was true, or I knew it was false, but yet you got it wrong? If you did that, you just showed hindsight bias. All right, so when I do this in class, there's always one or two students that's going to yell out, oh, I knew it was that. And then I'm like, oh, hindsight bias, got you. Operational definition. Operational definition is something that's extremely important when you do research. So an operational definition is a statement of procedures used to define research variables. An example could be if you want to measure how hardworking someone is, you could define it as overall GPA. Or even better, if you want to do a study to see how smart people are, well, how are you going to measure smartness? What you do is you have to come up with an operational definition on how are you going to define smartness. So you could say, oh, their overall GPA, or you could say test scores. Let's say you want to do a study with, how happy people are. Who's the happiest? Well, how are you going to measure happiness? That's very subjective. So what you do, you have to create an operational definition to measure happiness. It could be how many times they smile, how many times they laugh, or anything else that you can objectively count. All right, so you want to make it objective and not subjective. Or how sad someone is. Right? Create an operational definition could be how many times you cry. All right, so for homework, I'll give you numerous scenarios, and you're going to have to create the operational definition for the underlined part. Ethics, another thing that is extremely important when you do research. All right, so today we're going to talk about the 4 principles developed by the APA that must be followed. All right, the APA is the American Psychological Association. A lot of you guys have heard of APA style, like writing, when you have to cite things. So these are the main 4 they came up with. You might see other ones. These are kind of like the main 4. Different organizations have different ones. APA might even have a longer extension of it, but for our purposes, this is good. There'll be studies we talk about throughout the year that did not follow these, right? So they happened a long time ago, and these studies wouldn't be able to be replicated because they did not follow one or more of these principles. So let's go over the 4 principles. The first one, you must obtain informed consent of potential participants. Number 2, you must protect them from harm or discomfort. Number 3, you must treat information about individual participants confidentially. And number 4, you must fully explain the research afterwards. So sometimes when you do research, the participant doesn't really know what's going on in the research, and you can't tell them everything, because if you did, that might mess up your results if they had expectations. So, but after the experiment's over, then you must fully explain what was happening. And like I said, there's a lot of studies out there that did not follow these principles, and and some of these studies is why some of these principles were developed. There's one famous study that we don't talk about in here, but a lot of you guys have heard of the Tuskegee experiment, where they gave African American males syphilis. Now this pretty much breaks all the principles. Number 1, did they obtain informed consent? No. They did not ask their permission. They didn't even know they had it. Did they protect them from harm? No, syphilis is dangerous. Right? You can die from it. Henry VIII died of it. If you know your history, remember Henry VIII is the one who had 6 wives, beheaded 3 of them. And obviously they didn't know they had it, so they didn't explain the research either afterwards. All right, so there's a lot of studies, especially that one. There's numerous other ones that did not follow ethical guidelines, and so they would not be able to be replicated nowadays. All right, so we're going to talk about different types of research. So in here, if you want to leave space, because we'll talk about each one later, or you can just write it when we get to that slide. So there's descriptive research, which is like case studies, surveys, naturalistic observations. Then you have correlational studies, which just show a relationship. And then you have experiments, which show cause and effect. So first thing we'll talk about is case studies. A case study is an intensive examination of an individual hoping to discover a generalization. There's two main reasons we do case studies. One, they can often be a stepping stone for more research. And the second reason is we use them in unusual cases that provide insight to concepts we otherwise wouldn't be able to understand, like multiple personality disorder, which officially nowadays is called DID, which stands for dissociative identity disorder, like if you've seen the movie Split. All right, so a case study is an intense study, an examination of either an individual or small group of people. So like I said, the two main reasons. One is a stepping stone for further research, meaning that, research, if you're going to do a research experiment with hundreds or thousands of people, that could be very expensive. So before you get to that step and commit all those resources, you might want to do a case study first, where you just examine a small group of people. And then depending on your results, if the results are favorable, that now you'll go and do a big research project. The other reason we do case studies is because whatever you're studying is rare. There's very few people who have that. So like example, multiple personality disorder, DID, there's not a lot of people who have that, so you do a case study and study the few people who have it. Or like feral children, right? Those are very rare. So, if you happen to find one like Jeannie, which we'll talk about, then, that's a case study where we just focus like on one or a couple people. So either for, so the two reasons for case studies is either to see if further research is warranted, spending that extra money, or because it's rare, so you can't find a lot of people to do a big research project on, so you must do a case study. Surveys. Surveys is something you guys should be familiar with. You've done them. A lot of you guys have probably written them before. A survey is a technique that uses predetermined questions for people to self-report. The best results come from a random sample. All right, so a lot of us have done surveys. You need a random sample when you do a survey. So I know the statistics class at Thornton has done surveys in the past. Maybe if any of you guys are in statistics, maybe you guys will be doing them this year as well. So when they give them out, a lot of times they need to do a random sample. They just want, a lot of times students just want to give them to their friends. Well, then your results aren't going to be very accurate, right? Depending on what you're trying to find results for while you're doing the survey. If you just give them to your friends, well, a lot of times you think the same way as your friends. That's why you're friends, right? You have stuff in common. You're similar. Or maybe you just hand it to everyone in your class. Well, if you're trying to do a survey of like the senior class or the junior class or whatever, and you give them to everyone in your class, and let's say those are all the honor students, well, that's not a true, survey of the senior class. That's a survey of the honor students of the senior class, right? You need to give it to everyone, right? You need a true random sample. So sometimes I'll do online surveys. You can get paid for them sometimes. Well, before I can do the survey, I have to give them my background information to make sure that they don't already have people taking the survey that fit my background. Because if they have enough people that fit my background, then I can't do the survey, right? Because they need to diversify their response, right? They need a random sample. Naturalistic observation. Naturalistic observation is gathering information about people or animals in their natural surroundings. One of the key things about this, it doesn't explain behavior, it only describes behavior. Right? Only describes behavior. Doesn't explain it. You're watching people or animals in their natural habitat, and you just describe what you see. Right? So the famous one, a lot of you guys probably heard of Jane Goodall. She's the one that studied, I think it was gorillas for decades, kind of like lived with them. And so we learned a lot about them because she observed them in their natural habitat. And we learned about their behaviors, how they use tools, of course, simplistic tools, but they still use tools and things like that. So we do that with animals, but we also do it with humans. So a lot of times I think about like babies, toddlers, we'll observe them in their natural habitat a lot. So there's a famous study by Mary Ainsworth about child attachment with adults. And so they observed the children in their natural habitat, playing with toys, how did they react when their caretaker, their mother, was in the room versus stranger, and then how when they left and came back, right? So they're observing them in their natural habitat. Remember the key thing about this, it doesn't explain behavior, it only describes it. If you remember, this is from this couple slides ago, this was that, part of that descriptive research we talked about. All right, experiments. Key thing for experiments, it's the only way to describe cause and effect. Doing, a scientific experiment, following the scientific method, which you guys have heard of in pretty much every science class your whole life, right? You follow the scientific method, this is the only way to show cause and effect. And I got a little diagram here. A lot of you guys know what it is, right? You observe something. So then based off your observations, you come up with an hypothesis, which is an educational guess, right? A prediction of what's going to happen. So therefore you test that prediction, right? In a true, like a good experiment, you're going to test it multiple times over and over again to get the best results. If your results are not consistent with what you thought would happen, then maybe you have to modify your hypothesis, right? Until eventually you get consistent results. And if you get consistent results, and then you can develop a theory, right? Especially in psychology. Psychology is all about these different theories, and a lot of times that's where it comes from, right? Doing all these tests until you get consistent results, then you can develop a theory. That takes a long time. But remember, a couple things with experiments, only way to describe cause and effect, and it uses the scientific method. Correlational studies. A correlation shows a relationship, key right there, between two or more variables. Right? Correlation studies does not show cause and effect. Right? One can't prove the other. It just shows that there's a relationship between at least two or more variables. All right, so I'll give you guys scenarios, and you're going to have to tell me whether this is a correlation or whether this is an experiment. All right, whether it just shows a relationship or whether this shows cause and effect. So lots of examples of this, and I'll show you some on the next slide. But one example is parental involvement in academic achievement. So a lot of times A+ students, your top students, tend to have a lot of parental involvement. But why is that? Is it because the students do so well and the parents see them doing well, so they're proud of them, so then they're more involved with them? Or is it because they've always been involved in their lives and pushing them to do better and pushing them to study and read and all those things, and because of that, they become A+ students? Right? So when you have a situation like this where either way could cause one to happen, it just shows that there's a relationship there. It's not because you have involved parents, therefore that's why they're involved and they have an A+, right? You can't prove either way, right? All you can do is show a relationship, right? So that's what makes a correlation study. Key thing is correlation is not causation. That's what I was just saying. All right, correlation is not, that's why that's all caps, bolded, not causation. You can't determine cause and effect. Only an experiment can do that. It only describes a potential relationship. That's key. Doesn't show causation, only describes a potential relationship. It just says, hey, there's a relationship here, right? I can see this relationship. That's all it does. So I'll show you some examples of correlation data. So how do we show correlation, right? We use a scatter plot. So make sure you know we use a scatter plot to show patterns of correlation. The correlation coefficient is used to measure the relationship, which I'll show you on the coming slides. But each data point, you're going to have a number, right? Up to 1 or -1. That shows a strong relationship. That's the highest you can go to. So if it goes up to the right, like number 2, that's going to be a positive relationship. If it goes up to the left, like number 1, that's going to show a negative relationship. The closer you are to 1 is the stronger relationship. So number 1, that's a straight line. Those dots are straight. So that's going to be a -1.0. Number 2, it goes up to the right, but that's not a perfect line, right? So you always draw a best fit line. You've learned that in math and science classes before. So it's going to be a strong positive relationship, but not 1.0. That's going to be like a 0.8, 0.84, something like that. Number 3 and 4, you can draw some best fit lines, but the data points are all over the place. All right, so that's going to be very weak correlation. Number 5, perfect straight line. So that's a 1.0, positive, goes up to the right. Number 6, up to the left or down to the right, however you want to look at it. That's a bad line. But, so that's going to be negative. So that's like the exact opposite of number 2. So that's like a -0.8, -0.84. So here's some more examples at the top. Perfect straight line. So we have a 1.0. That's our correlation coefficient. In the middle here, we got data points all over the place, right? So that shows no relationship at all, right? If those are the results you get when you do a research, you wouldn't be able to use those results. At the bottom, goes up to the left or down to the right, however you want to say it. It's in a completely straight line, so it would be a -1.0 would be your correlation coefficient. All right, so here's one in more detail. This one right here, you notice how it goes up to the right. All right, so your correlation coefficient is positive 0.84. A lot of times, if you see a number on a scatter plot, r, like a small r equals a number, right, which will be 1 or less, that is your correlation coefficient. So we know it's positive because it goes up to the right. We know it's a strong relationship because it's pretty close to 1. All right, so sometimes you might have, if they might show you a scatter plot and you have to kind of guess what the number might be. Or you might just have to say whether it's a strong or weak relationship. If you see them, if your best fit line and your data points are close to it, now that's going to be a strong relationship. Of course, it's not going to be a perfect line. If it was, that would be a 1.0. And I doubt any true research study would have a perfect relationship. All right, so here's another example. This is a -0.35, goes up to the left barely. Right, it's almost a straight line. If it's completely horizontal, that would be a 0. All right, so we see the correlation coefficient right here, the little r with a negative point or -0.3. So we know it's negative because it goes down to the right. We know this is weak, right? So if you have data points like this, it could easily happen by chance. So if this is your results of the research you did, and you got dots all over the scatter plot like that, you can't really determine a relationship, right? So you can't say, oh, this shows a relationship with this. You can't come up with a conclusion at all if this is your data point. So correlations that just don't exist. So sometimes we see a correlation where there actually isn't a correlation. That's called a illusory correlation. All right, seeing the relationship when it expects in a set of data, even when no such relationship exists. So sometimes we expect certain things to happen, and it doesn't. All right, so stereotypes are a great example of illusory correlation. So one stereotype could be that everyone from small towns are nice. Therefore, whenever you meet someone from a small town, or every time you meet someone who's nice, you think they're from a small town. Now, of course, we know there's plenty of nice people from small towns, but yet there's plenty of nice people from cities as well. And you could do the opposite. Anytime you see someone that's like rude or mean, you might assume that they are from the city, from an urban area, right? Because, city people, they're rude because they're always in a hurry, things like that, right? So we stereotype people. That's illusory correlation. We see a relationship when there really is no relationship there. Here's some other examples of correlation and causation, or actually no causation. All right, so correlation is not causation. Let's look at this one up here first. The blue line shows ice cream sales. Notice as the months go on and it gets warmer, at least in the northern hemisphere, ice cream sales are going up, right? Peaking in July and August, because that's the hottest months. But also, shark attacks, which is the red line, goes up almost the same amount. Therefore, there's a relationship with ice cream sales and shark attacks. So do you think sharks like ice cream? So because more people are eating ice cream, sharks are going to eat more people or attack more people? Of course not, right? Both of these things happen when it's warm out. So when you're hot, you tend to eat more ice cream. And when it's hot, you tend to go to the ocean more. Right? You tend to go to the beach if you live on the coast, or you go on vacation there, so you have more people in the ocean. Therefore, it's more likely that a shark will attack somebody. If you look at some of these over here, this one says divorce rate in Maine correlates with the per capita consumption of margarine. Right? So margarine, fake butter. If you look at the data points, it all matches up. Therefore, somehow, if the divorce rate goes up, more people are eating margarine. If it goes down, less people are eating margarine. Now, there's a relationship there, right? But is that causation? Of course not. This one is Nicolas Cage films and female editors on Harvard Law Review. So Nicolas Cage is an actor. If you don't know him, Google him. He's in a ton of movies. So if you look as however many films he did is in each year was how many female editors of the Harvard Law Review there were. Right? So it shows a relationship. Obviously, one doesn't cause the other to happen. And the last one is, sorry for it being kind of small, but it's the number of people who died by becoming tangled in their bed sheets correlates with total revenue generated by skiing facilities. All right, so you see the two dots going through there. All right, I didn't even know, death by bed sheets was a thing, but apparently it is, and it correlates with skiing facilities, right? How much money they make. So somehow it's related. If you go skiing, more people are going to die by being tangled in their bed sheets. The one down here shows that there is a correlation between umbrellas and rain. Right? So does umbrellas equal rain? So every time I bring my umbrella out, is it going to make it rain? Of course not, right? There's no causation there. We just happen to have our umbrellas out when it rains to protect us from the rain. But just because you bring your umbrella out doesn't mean it's going to rain, doesn't cause it to rain. Right? There's a correlation there, not causation. The last example is Facebook driving the Greek debt crisis? So Facebook was founded in 2004. If you look by 2005 here, they already had 5.5 million users, including myself. So within 6 years, they had got to 750 million users. At the same time, you see the Greek debt go way up as well, right? So you see the correlation there. Now, because people are on Facebook all the time, did they stop working? Did they somehow cause this huge debt in Greece? Of course not. There's just a relationship there, but it didn't cause it to happen. There's a lot of other things that caused it to happen that we don't have time to discuss. All right, last slide. One more example of correlation. All right, so example is women who own horses live longer. The implied correlation there is horses make you live longer. But of course, that's not reality, right? Reality is if you own a horse, you can probably afford health insurance, right? Horses are expensive. So owning a horse doesn't make you live longer, but because you can afford to own a horse, you probably have more money, have better health insurance, therefore you can deal with illness and sickness and live longer, right? So there's a correlation there, but of course horses don't cause you to live longer.